Today's problem is rotate matrix. This problem, you can find it on interview bit. So pause the video at this point, go over to interview bit, look at this problem, rotate matrix, and then come back and we'll walk through the solution. Difficulty for this is medium. This is asked at Google, Facebook, Amazon. All right, problem description. You are given an n by n, so square, the square 2D matrix A representing an image. I mean, it's not important that it represents an image, but yeah, it could, images are represented as like matrices of pixels. Rotate the image by 90 degrees clockwise. You need to do this in place. Update the given matrix A. So this doesn't return anything. This method doesn't return anything. We're updating in place. So the solution is available to the calling method in the parameter, in the past parameter, which will be updated. If you end up using an additional array, you will only receive a partial score. Yeah, well, a couple things. One is we don't actually have a matrix here. We have a list of lists. I don't know why they present it to us as a list of lists. Isn't it called rotate matrix? Yeah, it's a rotate matrix, and then they give us a list of lists. To me, it's kind of ponderous to manipulate a list of lists as a matrix. I mean, you can do it, but you have extra gets and sets and so on. So we're going to convert it to a matrix, solve the problem, and then convert it back to a list of lists. What was the other thing? Oh yeah, additional array. Well, if you just create a second array and copy the values into it, it's not really much of a problem. So problem constraints. N is between 1 and 1,000. First argument is a 2D matrix A of integers. Output, rotate the given matrix. Examples. These examples are not very illuminating. I'm going to do I'll do a separate example, but you can kind of see what's going on in this first one. We're going to rotate it clockwise. So the 1 and 2, rather than being the first row, will rotate over here and become the rightmost column. So we'll have 1, 2 in the rightmost column. The 4 is going to rotate over here to the bottom left, and the 3 is going to rotate up here to the top left. Right? So now we have 1, 2, 4 is over here, 3 is over here. Okay. Anything else? All right. So let's take a look at this. Just realized I don't think I actually need this. When I use streams, I think it. Well, we'll find out. But I think that'll probably get implemented for us. This part here, this is going to convert a list of lists into a 2D matrix using streams. So the matrix is converted to a stream, and then each inner list of the list of lists will be converted to a primitive int array. So we got to convert a list to an array. We also have to convert integer objects to ints. So again, the list goes to a stream. We are going to map the integer objects to int values and make an array out of them. So now we've got these int arrays, and we have a stream of int arrays, and we're going to convert that into an array of arrays. So basically a 2D int array. You don't have to do it with streams. I mean, if you're more comfortable doing it with a nested loop, you can do that as well. Rows. Okay, so the rows. Let me pause this a second and write down a new example here. All right, so here, this I think is a little bit more workable example. This is we'll use this one here, this first one as the original matrix, and then this will be are over here, the rotated matrix. Now, when we say rotated clockwise, we don't mean rotate each element one position. It's kind of like turning the whole matrix onto its side, just flipping it 90 degrees. So the 1, 2, 3 wind up in the column over here, 1, 2, 3, and then you can follow it around. The 5, because it's in the center, stays in the center. But then we have 1, 2, 3. We have 6, 9, 8, 7, 4. So this is the rotated matrix. All right, we're going to do this in 2 steps. This is very similar to another problem. It's actually kind of a variation on the other problem, and that is transposing a matrix. So doing the transpose of a matrix means that the rows become columns and the columns become rows. Now, you can do that with any rectangular matrix, although if you want to do it in place, it has to be a square matrix. So let's look at what we're going to do first here is we're going to swap the top and bottom rows. Now, if there were more rows, again, we would swap the top and bottom rows. We would swap the second from the top with the second from the bottom and so on. But that's what this is doing. There's only one pass through this loop. Rows here is 3 in the example. There's 3 rows. 3 divided by 2, integer division is 1. So I is going to go from 0 to 0. That's it. J will go from 0 to 2. And so what we're going to swap is, in each case, we're going to swap ij, which is initially 0, 0, with rows 3 minus 0 is 3, minus 1 is 2. So we'll swap 0, 0 with 2, 0. Next time through, we'll swap 0, 1 with 2, 1, and the last time through, we'll swap 0, 2 with 2, 2. So we swap the top and bottom rows. Let me just go ahead and do that. Get rid of that, get rid of that, and then we'll rewrite it. 7, 8, 9, 1, 2, 3. All right. What have we accomplished here? Well, what we've accomplished is we've put it into the form where now all we have to do is transpose the matrix. The rows become columns and the columns become rows. So the 7, 8, 9 row becomes a 7, 8, 9 column. The 4, 5, 6 row becomes a 4, 5, 6 column. The 1, 2, 3 row becomes a 1, 2, 3 column. So the challenge in each case is, whether we're doing the rotate or the transpose, is you don't want to overwrite values that you're going to need later. All right? Now, to transpose a square matrix, we could go through all of the I's and J's. We could go through the loop step by step, but I can tell you what it's doing here. We're going to go through the first row, 0. We're going to go through 7, 8, 9. I is then going to go to 1. J is also going to go to 1 because J is equal to I. So we're going to process the 5 and the 6. Then I is going to go to 2. J is also going to be 2. So we're going to get the 3. We're just processing everything above this diagonal here. This diagonal. All right, so we don't have to worry about overlaying anything because we're just swapping across the diagonal. You'll notice that the diagonal in the rotated matrix is exactly the same, but that the numbers have been swapped over the diagonal. So the 4 and the 8 have been swapped, the 9 and the 1 have been swapped, and the 2 and the 6 have been swapped. So that is the solution. Rotate matrix is move the rows if you need to, and then you'll get it into a position where you can just do a transpose. Okay, now this last for loop here is just putting the values from the matrix back into into the list of lists. Okay, let's try and actually let's just run this first to make sure that taking out the stream didn't mess anything up. Okay, no, that looks good. Let me erase all those and submit. Okay, thanks for watching. If you found this helpful, hit like, subscribe, check out the playlist on screen. I have a lot of other videos that I think will help you level up your interview skills. Check the description for this video, also the pinned comment. There's a link to a free PDF called 12 Coding Interview Patterns that actually get asked. And if you're interviewing, I think it'll be a big help to you. It's free. You can download it immediately, and we'll see you next time.